Hi students, welcome back for another lesson in Visual Basic. This time we're going to go over creating text files, writing formatted output into the text file, and accessing the time clock in Visual Basic. So imagine you need to create a text file. Maybe you're going to log some data, maybe you're going to read in a text file and you're going to modify it. The first thing we need to do in creating the text file is decide where we're going to put it. So let's come over to Visual Basic. We're going to start a new project. It's going to be a Windows Forms app. Make this form a little wider. This time we're going to use the FileSaveDialog. So we're going to come down. Oops. Save File Dialog. Drag that on. Now before we can use it, we have to do some setup on the file save. So let's put a button on so we can actually call it. Here's my button. And see, let's change the text to something meaningful. I call file save. Much better. Double click the button. Now we're going to set up our file save. We actually have to create an object in memory. This is a little bit different. We haven't done this before. So I'm going to say dim save file dialog as new save file dialog. Close the parentheses. So that will create the object that we're going to work with. Now we have to tell it what file extensions do we want to put on this new file that we're creating. So we'll say save dialog1 dot filter. And this is where the syntax gets a little bit tricky, not bad. So one option we're going to do is a text file. Then to make this option appear in the drop-down, we use the vertical bar star.txt. Then vertical bar. I'm going to give the option for comma-separated values or a CSV file. CSV file. Vertical bar star.csv. There we go. So that should give us our varying options. Now we have to give the dialog a title. This will be appearing in the upper left-hand corner of the dialog window. Save file dialog1 title. And let's say choose a file name and pathway. Oops, we have a slight problem. Title equals. Go. That's good. Then it's simply a matter of saying show dialog. So save, oops, dialog1.showDialog. And that will actually put the dialog window on the screen. So at this point, let's run it. Make sure that everything's working properly. I'll hit F5. Hit my button. My title is correct. Choose a file name and pathway. Down as Save Type, I see my two options in the drop-down, so those are both good. And you can surf around just as you would with any other dialog. For the sake of this example, we'll just do the desktop. And when I hit Save, let's give it a file name. Okay, so no errors were thrown. Let's see what it actually recorded through the dialog. So we'll put a label and we'll send the output of the file pathway to the dialog. So the label, come over here, label one text equals file dialog1 dot file name. That should send the pathway to the screen. Let's run it and find out. I'll choose my desktop. Let's choose the CSV extension. Test file. So it would have written C users Stevens HP on the desktop test file.csv. Okay, not bad. But that didn't actually write the file. It didn't create anything. That simply set up a pathway that we can now use. So let's keep going with that idea. At this point, what I'd like to do is make things a little bit cleaner. Let's say dim. I'm going to declare a variable. Whoops. There. So this will give me a variable I can use to make things a little cleaner. Then I'm going to store my file pathway in that from the dialog window. Okay. There. Now we need to actually open a file. The way you do that is with the command my.computer.filesystem.write alt text, the file pathway, now we need to put whatever it is we want to write. So I'm just going to say some test output. And that will actually get written into the file. The last thing we need is a true or false statement. And the true or false is going to say either append to any existing file, meaning just add it at the bottom, or completely overwrite it if it's an existing file. So I'm going to say true. I'm going to tell it to append for fear that I might lose data if I accidentally overwrite something. I can always delete parts of files, but loss of data would be a real problem, especially if it's the night before a project's due. Not that that would ever happen. So let's see if this actually creates a text file. We'll run it. I'll hit my button. Call it test output. Put it on the desktop, hit save. Okay, so that should have created a file. If I now open my Windows Explorer, go to my desktop, there's test output. So it looks like it did create it. And when I open it, it says some test output. Okay, that looks good. I'm just going to push this off to the corner of the screen for the moment. So when we write to a text file, we're always sending text. But what if we want to send numbers? Let's do that. I need to shut down the execution of my program so I can edit it. And let's declare a variable. I will say dim my value as double. So I'm going to put floating point numbers in my value. And I will say for my value equals 1 to 25. I use the default step of 1, so I don't need to explicitly say that. Then I need to write it to the file. So I'm just going to copy right here. I'm going to say conversion.str. So I'm converting the value to a string. And then I'm going to add on to that string a Visual Basic carriage returned and line feed. VBCRLF. So that should write a value and then do a carriage return and jump down to a new line. So let's see if it does it. We'll hit F5. File save window pops up, looking good. I'll tell it to put it on the desktop. Let's just call it output. Well, call it output value so we don't conflict. There, that'll create it as a new file with no conflicts. I'll stop it. There's output values. And we see some test output because I had left in the literal. And here's something interesting. So because I did not put VBCRLF, it started putting the first value on the same line. Then it did the carriage returns and went down to 25. Okay, easy enough to fix. We'll get rid of that and store this window off to the side. So we'll go back into our code where we have the first line. We'll go up to the first literal statement, and we will add VBCRLF. So that should keep all of our numbers on the same line. Now, this is great. Everything's working fine. But suppose you need some kind of formatted output. Maybe you're doing a project where you're doing a currency calculator or dealing with money. We can format the outputs. Instead of going convert to string, we can say format my value. And now we have to tell it how we want to format. So for example, I can use a prearranged format of quote C. This says convert to currency. So I'll get a $, commas, and 2 decimal places. Let's run the code and see how that works. And this time, let's do a CSV file. All that's doing is adding the extension CSV. I hit save. Come back to my Windows Explorer. Now here's something interesting. Output values.csv is automatically associated to Microsoft Excel. So if I double click this, look at that. It came in as currency and it came in as individual cells. Whoops, it's off the screen. Sorry. So it came in individual cells with currency formatting. That's pretty nice. So if you have some kind of an assignment where you read a bunch of sensors and you want to chart data, CSV might be a very good way to go. Okay, let's try a different format. Shut down the program so I can modify it. So let's say that instead of currency, I want maybe 3 decimal places. Okay, I'm going to use the pound sign as a numeric holder. I put my decimal in. Then I can either use the pound sign as numeric placeholders, or I can use 0 if I always want to see 3 decimal places regardless of whether the end contains zeros. So using the pound sign for 3 places would chop it off anytime there is nothing in the decimal places. If I use 0, that will ensure that I always get 3 decimal places regardless if the end is 0. Let's run that. Let's try something different. Call it my file. And let's look at what's in my file. And as you can see, I have my integer value and I always have it with 3 decimal places. Okay. There are all kinds of preset formats. If you would like scientific notation, there's a pre-set up format for that. If you would like commas, let's do an example where we do commas. Oops. Program was still running, we'll shut it down. So let's make this something above 1,000. Say 1,000 to 1,025. So now I should get my first entry 1,000 decimal point 000. Let's see if we actually do get that. All the FileDialog. We'll call it new output. Save it. Close the program. And it did work as we said. We see 1,000, we see a comma in the placeholder, decimal point, and 3 decimal places. So that worked very well. So that's about it for writing files. It's simply a matter of establishing a file pathway, writing a string, and then true or false to whether you want to append or overwrite the files. Now let's go on to the next part of this lesson. Let's start looking at the time clock. And I think what we'll do is just get rid of all of this. And let's change our button to say, get the time. If you'd like to access your computer's time clock, there's a very simple way to do it. You're going to access the variable date.now. We'll come back over. We'll say label 1.text equals date.now. And let's see what happens. When I press the button, it writes out the month, day, and year. Then it writes out the current time. The time is actually 3:55 and 1 second in the afternoon. And every time I hit the button, that updates. That's pretty snazzy. We can also write that out in different formats if we choose. So let's say that we want the year to come last. As I check my notes. End this, date time now. And we'll say toString. Now we have to tell it what format we want to do. So just like last time, we'll go parentheses. Let's do month, day, year. Oops, need that in lowercase. and then 2 places for hours, colon, minutes, and seconds. Let's run it and see what we get. There we go. Month, day, year, and then military time, 15:57:07, which is correct. Now I'd like to go over a concept called Unix time, which is exceptionally useful for data logging. Unix time is nothing more than a decimal number which represents the number of seconds since January 1st, midnight, 1970. While that date is not particularly useful for any reason, it is useful in the fact that you can start an experiment, store the Unix time, and then record the difference between the start of your experiment and the current Unix time at any way throughout, and you can get the sample time into your experiment, or the duration that your experiment has just completed. So let's add another label. I'll add a label 2. Okay, and let's send the Unix time to that. We'll go under the button click, and we'll say label 2 dot text equals, and admittedly I'm going to paste this. So to access Unix time, it's simply datetime.now minus new date time, and here's how we state midnight of January 1st, 1970, and we're telling it return the total number of seconds. So let's run this code and see what it does. Pressing F5. This number represents the current Unix time. As you can see, it goes out to, in this case, 5 decimal places. It's not quite that accurate. I wouldn't trust any computer's Unix time value better than plus or minus maybe 50 milliseconds. But that can be just fine. Maybe you're doing some research and you're looking at the strength of sunlight over a 24-hour period, in which case 50 milliseconds is probably just fine. And you can see that every time I hit the button, the Unix time updates. So Unix time, very, very useful for data logging because it's simply a floating point value that's easy to subtract. Okay, and that concludes this lesson. Thank you for watching.